Hello and welcome to today's session about the most basic and commonly used terms in statistics. Statistics is the field which is concerned with developing and studying methods for collecting, analyzing, interpreting and presenting your empirical data. Here empirical data means the data which is based on, or you can say which is verifiable by observation or experience rather than any theory or pure logic. Okay, so you can present your data or you can convey your message through by presenting your data through two ways of statistical methods. These are classified into two types. Number one, descriptive statistics, and number two, inferential statistics. Descriptive statistics help us to summarize our data through numerical values or graphical visualization. Descriptive statistics also help us to identify and understand some very important properties in our data. It includes concepts such as, you must have heard it before, central tendency, dispersion, mean, median, mode, box plots, histograms, while inferential statistics help us in making decisions or predictions based on the data we have. Inferential statistics is more advanced topic because it will require a deeper understanding of the descriptive statistics. So inferential statistics is making a prediction of the data we have, and descriptive statistics is describing the data we have. So inferential statistics will include concepts such as hypothesis, probability. Let's understand a few other basic terms used in statistics, which are subject, population, sample and parameter. Let's understand each of these. So subject is the specific thing which we wish to observe or study. It could be a person, an animal or anything else. It is also known as observation. Now population is the entire set of topics that we are interested in. Population can include, for example, the female population or the adolescent population. Okay, but we cannot study the entire female population, the entire adolescent population. It's huge, and that's why we take a sample, and the sample is a group of people or object or item, whatever it is, from a larger population for measurement. That sample should be representative of the entire big population to ensure that we are able to generalize that findings from the research sample to the population as a whole. And then parameter is a value now which describes the characteristics of the whole population. For example, the population mean. The next important term in statistics is data. Your data will represent a factual information. It conveys a message to us. It tells a story. So your data can be divided into two categories, quantitative data and qualitative data. Quantitative data is also known as numerical data. These data have a numerical value and they can be counted or measured. Again, quantitative data can be further categorized into two types, discrete data, continuous data. Discrete data are those numerical data which can be counted but it cannot be measured. These data have only integers and they cannot be subdivided into parts. For example, the number of students in a class. A number of students in a class can be 25, 30 or 32, but it cannot be 25.7. Number of students in a class cannot be this sort of data, right? It can be a whole number, a whole integer only. It cannot be subdivided into further parts. The number of students in a class cannot be 35.2 or 35.7. It can be 35. Continuous data is a type of numerical data which is based on measurement. For example, the temperature in your city. Unlike discrete data, which involves only integers and cannot be subdivided into parts, the temperature in your city can be subdivided into parts. For example, 26.7 degrees Celsius. You can subdivide it into, you can make it very accurate by saying 26.7. It can be 27 only also, but it can be further subdivided into parts like 26.7, 28.9, 29, 29.2, like this. Qualitative data represent categories or group of data. That's why they are also known as categorical data and are usually written in text. These can be characteristics or names or anything else. Qualitative data is further classified into two types: nominal data and ordinal data. Nominal data cannot be ordered and cannot be measured. For example, gender. You can just name it like male and female. Hair color. It can be just the name of the hair color, which is black or brown. Ordinal data is the kind of categorical data with a set order or a scale to it. For example, first, second, third rank in a competition. So this sort of data is an ordinal data. In descriptive statistics, the mean, median and the modal values are the measures of locations or the measures of central tendency. Based on the data collected in a sample, the measures of location, they provide information about where the center of the distribution lies. In this particular picture, as you can see, that the mean, median and mode is explained through an illustration. Mode is the high point, median is the halfway point and mean is the average. Let's understand mean, median and mode with an example. The mean is the sum of all observations divided by their number n. For example, in this data set, 21 plus 25 plus 10 plus 8 plus 11. This is the number of cups of tea students drink in a week. And 5 is the total number of students. So if we have to find the mean, we add up 21, 25, 10, 8 and 11, which comes to 75, and we divided it by the number of students, which is 5. So the mean comes to 15. Median is the value that divides the series into an equal upper and lower range. So for example, in this data set, it has even number of values. The total number of values in this data set is 8. So we will do the mean of the middle two values, which is 4 and 5 here. So we do the mean of 4 and 5, which comes to 9, and then we divided it by 2. The median is 4.5. Or if the data set has odd number of values, which is 1, 2, 3, 4, 5, 6, 8. This is another data set which has odd number of values, which is 7. So you pick up the middle number and that becomes your median. So here it is 4. Now the mode is the value of a distribution that occurs the most often in your data set. So in this data set 2, 3, 7, 10, 7, 8, 3, 9, 3, 6, 5, 3, the value which occurs most often is 3 here. So the mode is 3. Next important term used in statistics are outliers and standard deviation. Outliers are the data points which will differ from the other data points, and if they are present in your data, it can lead us to incorrect conclusions. While standard deviation is a summary value that indicates how far our data point deviates from the mean. It is used to determine the spread of our data. The closer the standard deviation is to 0, the closer our data points are to one another. So the standard deviation is a very valuable summary that informs us that our data set has some outliers. A bar chart is a type of data visualization used for categorical data. We use it to graphically show the frequency of categorical data, that is, the number of times a categorical data point occurs. So, although the graphs can be plotted vertically, which is bars standing up, or horizontally, bars lying from left to right, the most common type of bar graph is vertical. So the horizontal x-axis represent the category, the vertical y-axis represent a value for those categories. A histogram is similar to a bar chart. It shows the frequency of your numerical data called the heights, but it groups the numerical data points into bins or ranges. The difference here is that the data points are represented in ranges. So the difference between bar graph and histogram is that bar graph is the graphical representation of categorical data, while histogram is the graphical representation of group data but in a continuous manner. Also, you will see that there is equal space between each pair of consecutive bars in bar graph, while in histogram there is no space between the consecutive bars. Scatter plot is another popular form of graphical representation of data. It can represent the correlation between quantitative variables in a graphical summary. The scatter plot also allows us to visually observe if there are any outliers in our data collection. So the data points or the dots which appear on the scatter plot, those represent the individual values of each of the data points, and it also allows to see or identify any pattern when looking at the data holistically. A hypothesis is an assumption that is neither confirmed or not disproved. In research, a hypothesis is stated at the start and the goal is to either reject it or maintain it. Usually, hypotheses are formed during the literature search. Based on the literature search, you can then justify why you have formulated that hypothesis. So, a hypothesis is a precise testable statement of what the researcher predicts will be the outcome of the study. It involves proposing a possible relationship between the independent variable and the dependent variable. Independent variable is what the researcher can change in his or her experiment, while the dependent variable is what the research or your experiment intends to measure. A hypothesis tests are used when we want to draw the conclusions about the population based on the sample. Hypothesis tests are used to prove about the population with the sample. There are various types of hypothesis tests which are available: t-test, chi-square test, correlation analysis, regression analysis, ANOVA, etc. If you like today's video, please give a thumbs up and do subscribe to my channel. Thank you.